Welcome to the iSet Robotics MOOC M2, and this is Unit 2 already, and we're considering the color sensor and then the flow control. I'm Dr. Patricia Goos, and I shall be presenting this unit. So the unit objectives are the attachment of sensors to the robot, just as in Unit 1, and then the programming of specific tasks. In this case, we are going to focus on the color sensor, so find a line and follow a line, and then the need of the color sensor calibration. When we focus specifically on the color sensor, it must be very rigidly attached and the wires must be connected correctly. So what color can then a color sensor detect? The first is the color on the spectrum, so on the rainbow spectrum, greens and yellows and reds, and then the sensor will show a multicolor light. However, if the color sensor is being used to detect ambient light, like the room, the natural light, the sunlight, the sensor is usually a blue, dim blue color. If the same color sensor is being used to measure reflected light intensity or RLI value, the RLI value is in a range from 0 to 100. So at 0, there is reflected light, and 0 is reflected, so it's a very dark surface. Whereas if the value goes up to 100, then it must be very light because almost 100% of the light is being reflected. And the sensor is then shown as a red, and it measures the amount of this light that is reflected. And you can confirm these values in the port view. So how do you attach a color sensor then to a robot? Well, that depends on what you want to actually measure. If you are facing it forward, you're detecting the color in front of your robot. If you are attaching your color sensor down in front of the robot, then you are trying to find or follow a color or a line. If you're putting it down at the back of the robot, then you're reversing to find a line. If you're having it up, then you can maybe detect a light, the ambient light, or detect a change in the ambient light, or you can use it to detect a color. Usually when you connect a color sensor, it's usually with connectors or beams, and then the function, you need to obviously attach it to the brain in one of the input ports. So to detect a color sensor, detect a color line. So the assumption is that you have a color line, usually maybe insulation tape on a surface, on a white surface, and then you set the robot to start moving towards the line. You have a color sensor attached in the center in the front of your robot, and then you go and find the color. And if you find the line, then obviously you must stop. The thinner the line, the slower the robot must move to ensure that you actually pick up the line then. So if you want to detect the ambient light, which is the light in the room, then there must be no shadows. So the color sensor will then be facing upwards to detect any change of light. So you could maybe shine a torch there, or use a different kind of light, but that would be the ambient light then. So to detect a color sensor for an RLI value, it must be very close to the ground, usually just less than maybe half a centimeter, and then you must make sure that all other light is blocked out so that you don't get any interfering light. Then the threshold value is then the value at which you're swapping over from all light being reflected to all light not being reflected or absorbed in this case. So you attach, and it's usually recommended if you're going to get a reflected light intensity value, if you're following the line on the left hand side, you attach your color sensor in front of the left wheel, and likewise if you're following the line on the right hand side, you'll then need to attach the color sensor in front of the right wheel. So in the programming activities of this unit, we are going to use the flow control structures, so the loop and the switch, and then we're going to interpret the sensor data or sensor input, and we're going to control then the functioning of the robot using the flow control structures and then your input from your sensors. So we've got now here a color sensor attached to port number 3, and if you can see the selection for the options, it's a color sensor and we're trying to detect color, and we've chosen specifically the red color, color number 5. So in this case, the robot is going to, in the loop, continue going or moving until it detects a red color in port number 3, and then it will stop. So just by expansion of the colors, these are the colors. You can also select multiple colors. So you can say you can continue moving until you see green or yellow or red. So in that case, you've got 3 options to make the robot stop. So in this programming icon, you can see that the color sensor is measuring reflected light intensity. And so the little diagram shows the light being reflected with the arrow. So it's reflecting off the surface. So it is less than, you choose less than, and then 50 is your kind of your threshold value under normal circumstances. But you can measure and determine that 50, which is then called your threshold value. So if we were to read this code, we're going to read ambient light, and we're going to continue moving until the ambient light is less than 50. So until it becomes dark, we're going to continue moving. So that would be something moving along, and then you suddenly switch off all the lights, and then it'll stop. It'll only start moving again when your light shines on, or when a torch shines on it. So in this case, the robot is going to keep moving, okay, until the ambient light is greater than 50. So that means it's going to become light. There's going to be lots of light, and then it will stop. So as soon as you shine a torch on it, it'll stop. I've included this example because the loop structure and the weight structure are very similar. And I just need to explain that for when you have a weight symbol or weight structure, it only refers to the icon just in front of it. So this doesn't allow you to have multiple steps that are repeated. So if you have it in a loop structure, everything inside the loop will be repeated. If you have a weight, only the icon just before it will be repeated. So if you read this, it says continue moving straight until the ambient light, and then can you see there's an increasing arrow? So until the ambient light increases by 10%, and then you must stop. All right, that's again until the sun comes up or until you shine a torch on the robot. Okay, so if you hold your robot and you are connected with a USB cable, or you've got Bluetooth, to calculate your threshold value, you kind of put the color sensor onto a light surface. It'll give you your maximum value, and then onto a dark surface that gives you the minimum value, and then the threshold is then the value between the minimum and the maximum values. And this is to allow your robot then to follow a straight line. It might be a little bit ziggy-zaggy at the beginning, but you've got to start somewhere. So this example allows you to follow a line on the left-hand side. If you're following a line on the left-hand side, the control is if you have less than 50. If you're going less than 50, then the road is becoming very dark, all right? Which means you're probably veering towards the center of the road. You must now get back onto the side of your road. So what happens here is that the motor C then goes on and motor B goes off, so you're taking it just to the side again. And likewise, if you're going to see too much reflected surface, which means that you are off the road, then you'll need to put C off and B must go on, so it gets it back onto the side of your road. So using a color sensor, it's really important that you calibrate to ensure that what you think the robot sees is what you're actually seeing. Reflected light intensity is often used to find a line or follow a line in a competition, but the value definitely needs to be confirmed or measured. Please don't assume that what you think the robot sees is what you actually see. So here are some references on the internet available with the color sensor. It's about following a line, there's a stopping at the line, there's some really basics, and then crossing over to intersection. I've added another one, but that is kind of really the next couple of 2 steps or 3 steps ahead, but it's kind of where calibration is going, is where you store the value that you read in a text file. And so when your program is executing and it doesn't quite match the text file data that you have, then you know something is wrong. Okay, so we've come to the end of Unit 2. Please do complete Unit 2's quiz. Try and build at least one of the activities and try and program at least one of the activities and see if you can follow along. That'll be awesome. Again, if you have any problems or you're struggling, please don't hesitate to contact me or one of the team members, and we'll see you in the next unit. Thank you so much.